For centuries, humanity has stared into the night sky wondering the same question. Are we alone? Every generation has searched for an answer, from ancient astronomers tracking the stars with their eyes to modern scientists building machines powerful enough to look billions of years into the past. Yet despite all our discoveries, the universe has remained silent. Until now. A distant world orbiting the closest star to our Sun has captured the attention of astronomers around the globe. During recent observations, researchers detected unusual infrared emissions coming from Proxima b, a rocky exoplanet located just over 4 light-years away. While no one is claiming this is proof of alien technology, the strange patterns have sparked one of the most exciting scientific discussions in years. What exactly are these mysterious signals? Could they be the result of unusual geology? A rare atmospheric effect? Or could they represent something humanity has never observed before? Proxima b orbits Proxima Centauri, a small red dwarf star that belongs to the Alpha Centauri star system. Since its discovery, the planet has fascinated scientists because it lies inside the region where temperatures might allow liquid water to exist under the right conditions. But living near a red dwarf comes with serious challenges. These stars frequently unleash enormous stellar flares capable of flooding nearby planets with intense radiation. For years, many astronomers believed such violent activity would make life nearly impossible. Yet newer computer models suggest that if Proxima b possesses a thick atmosphere or a strong magnetic field, parts of the planet could remain surprisingly stable. One unusual feature makes this world even more intriguing. Scientists believe Proxima b is likely tidally locked. One hemisphere permanently faces its star while the opposite side remains in endless darkness. Imagine standing on a world where the sun never rises, or never sets. Such an environment would create completely different climates from anything found on Earth. The line separating eternal daylight from permanent night could become the most habitable region on the planet, where temperatures remain moderate enough for liquid water and perhaps even life. Then came the observations that changed the conversation. During detailed infrared studies, astronomers noticed faint but recurring light signatures that appeared far more organized than random background noise. Instead of flashing unpredictably, the emissions seemed to repeat over multiple observations. Scientists immediately began searching for natural explanations. Could volcanic eruptions be responsible? Perhaps glowing lava fields? Maybe charged particles interacting with the atmosphere? Each possibility remains under investigation. At the moment, there is no evidence proving the lights are artificial. But because the signals appear unusually consistent, researchers believe they deserve careful study. This is where the James Webb Space Telescope changes everything. Unlike ordinary telescopes, Webb specializes in infrared light, allowing it to detect extremely faint heat signatures invisible to human eyes. It can analyze the chemical makeup of distant planetary atmospheres and identify molecules associated with weather, geology, or even possible biological activity. Every observation provides another clue. Tiny differences in temperature. Unexpected chemical combinations. Subtle variations in reflected light. Together, these pieces help scientists reconstruct the conditions on worlds trillions of kilometers away. Some researchers have proposed an intriguing possibility. If an advanced civilization existed on a tidally locked planet, permanent darkness might encourage large-scale artificial illumination. Cities, industrial facilities, transportation networks, or massive energy systems could theoretically produce detectable infrared signatures. This idea remains entirely speculative. No scientific team has announced the discovery of alien cities. But the fact that modern telescopes can even test such ideas demonstrates how dramatically astronomy has advanced. For the first time in history, humanity possesses instruments capable of searching not only for life, but perhaps signs of technology itself. And this may only be the beginning. If the unusual light patterns on Proxima b continue to withstand scientific scrutiny, they could transform the search for life beyond Earth forever. For decades, astronomers focused almost entirely on biosignatures, chemical clues such as oxygen, methane, or water vapor that might indicate living organisms. Today, another exciting field is rapidly growing: the search for technosignatures. A technosignature is any detectable evidence that advanced technology may exist on another world. Artificial lighting, industrial pollution, massive orbital structures, directed laser beams, or unusual heat emissions that cannot easily be explained by natural processes. Although none of these have been confirmed on Proxima b, scientists are now developing techniques capable of searching for them with increasing precision. Future space observatories will push these investigations even further. Powerful ground-based telescopes currently under construction will use enormous mirrors and adaptive optics to observe nearby planetary systems in extraordinary detail. Planned space missions may eventually photograph Earth-sized planets directly, allowing researchers to study continents, oceans, cloud systems, and seasonal changes. Engineers are also designing giant star-shaped spacecraft. These flower-shaped structures would fly thousands of kilometers in front of telescopes, blocking a star's overwhelming brightness so that nearby planets become visible. With technology like this, worlds that currently appear as tiny points of light could someday reveal remarkable details. Yet every extraordinary possibility demands extraordinary evidence. Science advances through careful testing, repeated observations, and healthy skepticism. Many mysterious signals throughout history have eventually been explained by instrument errors, unexpected stellar activity, or previously unknown natural processes. That is why astronomers continue examining Proxima b from every possible angle. If the mysterious emissions disappear, researchers will investigate why. If they remain, scientists will compare them against every known physical explanation. Only after years of careful study could anyone begin considering more extraordinary conclusions. Regardless of the final answer, Proxima b has already accomplished something remarkable. It has inspired new questions. It has driven improvements in telescope technology. And it has reminded humanity that the universe still contains countless mysteries waiting to be explored. Imagine, for a moment, another civilization standing beneath its own unfamiliar sky. Perhaps they have built observatories of their own. Perhaps they wonder whether intelligent life exists somewhere among the distant stars. Maybe, at this very moment, they are looking toward our sun while we search for them. Whether or not those mysterious lights ultimately prove to have a natural origin, they symbolize something much larger than a single planet. They represent humanity's growing ability to investigate worlds once thought forever beyond our reach. Every new telescope expands our vision. Every new discovery reshapes our understanding. And every unanswered question reminds us that exploration is far from over. The James Webb Space Telescope is more than a remarkable scientific instrument. It is a bridge connecting our small world to an unimaginably vast universe. One observation at a time. One mystery after another. One discovery closer to answering the oldest question ever asked. Are we truly alone? Until that answer arrives, the lights of Proxima b will remain one of astronomy's most fascinating mysteries, inviting scientists, dreamers, and explorers alike to keep looking toward the stars. Because somewhere beyond the darkness, the next great discovery may already be waiting.